Hello everyone, my name is Tanis Reddy. I'm studying in first year of engineering in the branch of cybersecurity in Sri Venkateswara College of Engineering. Now I'm going to explain on the topic of decision control and looping statements. Decision control and looping statements. Decision controls and looping statements are fundamental programming concepts that enable developers to write complex and dynamic code. These constructs allow programs to make informed choices, repeat actions, and execute logic based on specific conditions. By mastering these essential programming techniques, developers can create robust, efficient, and user-friendly applications that can adapt to a wide range of scenarios and user inputs. Conditional if statements, that is, if else. If else basics. The if else statement is a fundamental decision making construct that allows a program to execute different code blocks based on specific condition. It enables developers to make choices and take appropriate actions based on the current state of the program. Evaluating conditions. The conditions in an if-else statement is typically an expression that evaluates to a Boolean value that is true or false. This could be a simple comparison, a complex logical expression, or even a functional function call that returns a Boolean result. Nested if-else. If-else statements can be nested, allowing for more complex decision-making logic. This can be useful when there are multiple conditions to evaluate or when the decision-making process requires a series of checks. Conditional statements. Switch case. Switch case. The switch case statement is an alternative to if-else construct, providing a more concise and readable way to handle multiple conditions. It is particularly useful when you have a variable or expression that needs to be evaluated against multiple discrete values. Handling multiple cases. Each case in a switch case statement represents a specific value or condition that the program needs to handle. The code block associated with the matching case will be executed, allowing for efficient and organized decision making. Default case. The switch case statement also includes a default case which is executed when the value or condition does not match any of the specified cases. This provides a safety net and ensures that the program can handle unexpected or unspecified scenarios. Iterative statements for loops. Initialization. For the for loop begins with an initialization step where a control variable is set to a starting value. The variable is used to track the progress of the loop and determine when it should terminate. Condition evaluation. The loop evaluates a condition, usually involving variable to determine whether the loop should continue executing as long as the condition is true. The loop body will be executed. Iteration. After the loop body is executed, the control variable is updated according to a specified increment or a decrement. This allows the loop to move forward and eventually reach the termination condition. Iterative statements. While loop. Condition evaluation. The while loop begins with an evaluating a condition which is typically a Boolean expression as long as condition is true. The loop body will continue to execute execution. When the condition is true, the loop body is executed allow the program to perform a set of operations or actions repeatedly. Iteration. After the loop body is executed, the condition is re-evaluated. If the condition is still true, the loop will continue to execute. This cycle continues until the condition becomes false, at which the point of the loop terminates. Iterative statements. Do-while loop. Guaranteed execution. The do-while loop is similar to the while loop, but with one key difference is the loop body is executed at least once regardless of the initial condition. Conditional value. After the loop code is executed, the condition is executed. The condition is true. The loop will continue to execute. The process repeats until the condition becomes false, at which the point of the loop terminates. Useful or input validation. The do while loop is particularly useful for input validation scenarios where you want to ensure that the user provides a valid input. Before proceeding with the program's logic, flexibility in condition. The condition in a do-while loop can be as similar as complex as needed, allowing for a wide range of uses cases and decision-making scenarios. Nested structure. Nested loops occur when a loop statement is placed inside another loop statement. This allows for the execution of complex multi-dimensional algorithms and data processing tasks. Layered execution. The inner loop is executed incompletely for each iteration of the outer loop, creating a layered execution pattern that can handle multi-dimensional data structures and problems. Efficiency considerations. Nested loops can significantly impact the performance of a program, so it's important to carefully design and optimize them to ensure efficient execution, especially when dealing with large data sets. Readability and maintainability. Nested loops can make code more complex and harder to read and maintain. It is important to balance the need for nested loops with clear, well-structured code that is easy to understand and modify. Controlling loop execution, break, and continue. Break statement. The break statement is used to immediately exit a loop, regardless of whether the loop's condition is still true. This can be useful for terminating a loop when a specific condition is met or for handling exceptional cases. Continue statement. The continue statement is used to skip the current iteration of a loop and move on to the next one. This can be useful for selectively executing certain parts of the loop body based on a specific condition. Conclusions. Decision controls and looping statements are essential tools in a developer's arsenal, enabling them to create robust, adaptive, and efficient programs. By mastering these concepts and applying best practices such as clear naming conventions, modular design, and performance optimization. Developers can write code that is not only functional but also maintainable and scalable. As you continue to explore and experiment with these programming constructs, remember to keep your code clean and well documented and aligned with industry standards. With dedication and practice, you will soon become a proficient and confident programmer capable of tackling complex and delivering exceptional software solutions.